Hello, welcome to Astronautics for Exploit. This is Dr. Ayeshola Ogundele. Interplanetary Internet, a next-generation space network architecture, an actualization of virtual journey to the Moon, Mars, and beyond. The focus points are as follows: Interplanetary Internet, challenges of interplanetary Internet, interplanetary Internet protocols and standards, and future interplanetary Internet architecture. The Interplanetary Internet, a proposed space computing network consisting of a set of network nodes, such as Earth ground stations, orbitals, and landings of the planets that can communicate with one another, has been evaluated to be a potential trillion-dollar business. Based on the increase in interest in digging deeper into the cosmos to unravel the mysteries of the universe, several government space agencies, private space companies, and academia are investing in the research and development of interplanetary internet. The design strategy is to power the interplanetary internet using relay stations and satellites that are interlinked together for the purpose of accelerating messages from one planet to another planet and through the interplanetary space. Presently, both SpaceX and Blue Origin are contending to develop interplanetary internet that will link Earth to the Moon, Mars, and beyond. Efforts are in top gear to map out plans on the development of future interplanetary internet that will help to interlink orbitals, robotic explorers, and human crew to the planet. Also, strategy is being developed to evolve present set of internationally standardized space data communications protocols into an operational interplanetary internet. Presently, 5 orbitals are orbiting the Mars Odyssey, Marvin, and Mars Recognition Orbital, and the Mars Express and Trace Gas Orbital, being used as relay stations in the interplanetary system, and are transmitting images and data from the Perseverance and Curiosity rovers to the Deep Space Network antennas. Interplanetary Internet. The Interplanetary Internet is a conceived computer network within the interplanetary space. It consists of a set of network nodes that can communicate with each other. Several space agencies and private space companies, such as NASA, ESA, SpaceX, and Blue Origin, are working towards actualization of this concept. The nodes are the planet's orbitals, landers, and the Earth ground stations. The picture here shows SOSTAR persistent space communication services that provide leading narrowband and broadband data and voice services for space missions and operations. The orbitals collect the scientific data from the Curiosity rover on Mars through near-Mars communication links, transmitting the data to Earth through direct links from the Mars orbitals to the Earth ground stations via NASA Deep Space Network, and finally, the data routed through Earth's internal internet. SOSTAR Wi-Fi access points securely connects Wi-Fi-enabled devices to support crew communications, payload integration, experiment, and more is shown in this picture. Interplanetary distances, one of the factors that led to the delay of interplanetary communications, are necessitating the need to develop a new set of protocols and technologies that are tolerant to large delays and errors. The Interplanetary Internet is a store and forward network of internets that is often disconnected as a wireless backbone fraught with error-prone links and delays ranging from tens of minutes to hours even when there is a connection. ESA's Moonlight Initiative, Lunar Communication and Navigation Services is shown in this picture. Challenges of interplanetary internet. Based on various factors, many challenges are faced by the interplanetary space system. Examples are as follows: long distances and the motion between planets, payload limitation, line of sight obstruction, and lack of fixed infrastructure. Interplanetary Internet coverage is shown in this picture. Interplanetary communication is greatly delayed due to the interplanetary distances and the motion of the planets. The delay in interplanetary communication is variable and long, and it ranges from a couple of minutes from Earth to Mars to a couple of hours Pluto to Earth, depending on their relative positions. Satellites circling Mars, which could help send information back to Earth over an interplanetary internet, is shown in this picture. On Earth, humans are only a fraction of a light second apart, making Earth communication nearly instantaneous over the internet. As one moves farther out into space, however, there is a delay of minutes or hours because light must travel millions of miles instead of thousands of miles between transmitter and receiver. High-rate delay-tolerant networking is shown in this picture. Payload limitation is another challenge of interplanetary space internet. Satellites can only carry a small payload, which poses challenges to the power, mass, size, and cost of communication hardware design. An asymmetric bandwidth be the result of this limitation. High-powered antenna that will improve communication with these space probes are often too heavy to send on a space mission because the payload must be light and efficiently used. Illustration of internet spreading across the solar system is shown in this picture. Anything that blocks the space between the signal transmitter and receiver can interrupt communication. The participating nodes in the specific planet-to-planet communication keeps changing over time due to the constant motion. The routes of the planet-to-planet communication are planned and scheduled rather than being opportunistic. Illustration of social space communications in space is shown in this picture. Interplanetary Internet protocols and standards. The protocol used for the transmission of spacecraft instrument data over the Deep Space Channel is defined by the Consultative Committee for Space Data Systems Packet Telemetry Standard. A packet is a block of data with length that can vary between successive packets ranging from 76 to 5,542 bytes, including the packet header. Data sent from a spacecraft instrument is transmitted using one or more packets. Sister Wi-Fi access point is shown in this picture. Packetized data is transmitted via frames, which are fixed-length data blocks. The size of a frame, including frame header and control information, can reach up to 2048 bytes. Packet sizes are fixed during the development phase. Because packet lengths are variable, but frame lengths are fixed, packet boundaries usually do not coincide with frame boundaries. Building of interplanetary internet between the Earth and the Mars is shown in this picture. Future interplanetary internet architecture. Presently, study is ongoing to develop future technical architecture of an interplanetary internet. The study idea is to blend ongoing work in standardized space communications capabilities with state-of-the-art techniques being developed within the terrestrial internet community, with a goal of achieving end-to-end communication in a multi-network interplanetary environment. Delay disruption-tolerant networking enables the use of multiple paths and providers to efficiently deliver data rates, shown in this picture. Use Internet or Internet-related protocols to form local networks in low delay, relatively low noise environments such as around the Earth, within a free-flying spacecraft, on and around another planet. A specialized deep space backbone network of long-haul wireless links interconnecting these local internets is another future interplanetary internet architecture endeavor. SMS Express, relaying data from the Soron rover, is shown in this picture. Another feature interplanetary internet architecture is the resulting internet, which will consist of a network of internet, just as the familiar TCP/IP should unite the Earth's network of networks into the internet. The interplanetary internet will employ a new overlay protocol concept called building to tie together a set of heterogeneous internets. Illustration of interplanetary internet strategy is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Interplanetary Internet Presentation, a next-generation space network architecture and actualization of virtual journey to the moon, Mars and beyond. Presented by Dr. Ayansola Ogundele, with the focus point Interplanetary Internet, Interplanetary Internet Criteria, and Interplanetary Internet Protocols and Standards, and future interplanetary internet architecture. Thank you.